Hello guys, welcome to all of you. Let us understand about power rating problems of zener diode. Here, if we have to calculate minimum power rating of zener diode, then we can say that this minimum power rating of zener diode will be equal to the maximum power dissipation across zener diode. And this can be represented by Pz max and its value will be equal to Iz max into Vz. Here, Iz max is the maximum current which can flow through zener diode without damaging it. And if we have to calculate minimum power dissipation across zener diode, then we have to find out Iz minimum into Vz. Here minimum power dissipation can be represented by Pz minimum, and for the calculation of minimum power dissipation we will use Iz minimum value, and it is also known as knee current of the zener diode. This is the minimum current which is required for switching on to zener diode to operate in breakdown region. Vz is the breakdown voltage of zener diode. Here we have to remember for using these formulas that if minimum power rating is asked in the question, then we should not confuse with minimum word here, as we should not use this Pz minimum formula that can be written as Iz minimum into Vz, since minimum power rating of a zener diode is the maximum power dissipation across a zener diode. Here is a question asked in GATE 1996. In this question it is said that a zener diode circuit which is shown here has a knee current of 5 milliampere. Knee current is given as 5 milliampere and maximum allowed power dissipation of 300 milliwatt. Means P maximum is given as 300 milliwatt here. What are the minimum and maximum load current that can be drawn safely from the circuit, keeping output voltage V0 constant at 6 volt? We have to find out minimum and maximum load current flowing through this load. These are the options which were given in the question. Now let us see how can we solve it. In the question it is given that knee current, that is the Iz minimum current, is 5 milliampere. Breakdown voltage of zener diode is 6 volt. As we have to achieve V0 is equal to 6 volt, means constant 6 volts should be available across this load. Pz maximum can be written as Iz max into Vz. Here Pz max value is given as 300 milliwatt. So Iz max can be calculated by using this formula, that is Iz max is equal to Pz max upon Vz. As we have seen that Pz max value is 300 milliwatt and Vz value, that is the breakdown voltage of this zener diode, is 6 volt. If we put these values, then we can get 50 milliampere. So Iz maximum current, that is the maximum current which can flow through this zener diode while safe operation of this zener diode. If we apply KCL at this node, then we can write as Is is equal to Iz plus IL. As we can see, Is value can be written as Vs minus Vz upon Rs. So we can calculate Is is equal to Vs minus Vz upon Rs. By putting these values, we can get Is value is equal to 60 milliampere. Here we can see that these voltage sources Vs and Vz are constant voltage sources. So here we can get a constant current, as this Rs resistance is also constant. As here we can see that if we change the value of Iz, then IL value will also change, since this Is value is constant. So if we assume that minimum current is flowing through this zener diode, which is required to operate this zener diode in breakdown region, that is the Iz minimum current, or we also can say this is the knee current of the zener diode, then IL current achieved at this load will be maximum. If we say that maximum current is flowing through this zener diode, then IL current will be minimum. Means we cannot flow more than this current in the zener diode for safe operation of the circuit. So this equation number 2 can be achieved as Iz maximum current flowing in the zener diode, then IL minimum current will flow across this load resistance. If we use this equation number 1, then Is value is calculated at 60 milliampere. We put 60 equal to Iz minimum is given as 5 milliampere. So we put here 5 plus IL maximum. So IL maximum can be calculated at 55 milliampere. If we put values in this equation number 2, here Is is 60 milliampere and Iz maximum, which is calculated here, is 50 milliampere. We put these values, then we can find out IL minimum. So IL minimum can be calculated at 10 milliampere. So in this question, we can say that if value of load current is varying in this range, that is the between 10 milliampere and 55 milliampere, then at the output V naught value will be equal to 6 volt constantly. We can say option C is our answer.